Okay, moving on, we're now looking at solutions of trig equations. And so the first thing to note down, as is put down here in our heading, is that there are an infinite number of solutions to trig equations, and we'll have a look at that in a moment. And so we're usually given a domain to give our solutions in. All right, so our first example here is solve cos theta equals a half. So cos of what angle, or angles, equals 1/2. So the infinite nature of which I'll show you now. We've been doing some work on graphs, and this is the best way really of showing this. Is that if we know this cos curve looks like this, but remember it's periodic in nature and just goes on forever. This is the bit we normally graph, and it sort of goes down here as well, doesn't it? And off it goes. So if we want to solve this equation here, cos theta equals 1/2. So what that's saying is this is theta here. This is theta. That's the theta axis, and this is the this is the numerical axis. So y equals, this is the y-axis. But in this case, we're solving for cos theta equals 1/2. So we go to 1/2 here. And remember, this is 1 up here, and this is -1 down here. So 1/2, about halfway up. That means what we're looking for are these solutions here. So whenever y equals 1/2 on y equals cos theta, we have a solution, don't we? We have a solution to this equation. So you can see that we go across here and we're drawing a horizontal line across at 1/2, and we're gonna bump into this cos graph an infinite number of times, aren't we? I'm just making an endless series of solutions here, but this will go on forever. You don't need me to sort of continue doing that. So on this page alone, I've got 3, 4, 5, 6, 7, 8, 9 solutions, but that's just because I only graphed it across that domain. So we will have an infinite number of solutions. That's the first thing to acknowledge here. What those solutions are, well, we can go ahead and find those in a moment, but we will be given a domain to work within, and in this first example, and in many examples, I suppose the most common is to be told that let's take solutions between 0 and 360 degrees. So in fact, we are just interested in this section of the curve here from 0. Right, this is for cos theta, so our period is 2 pi, or 360. So that's 360 there. So that's 360. So we are just going to get the 1, 2 solutions, and you can see where they are. They're in quadrant 1. This is quadrant 1 here. Quadrant 2 is, that's quadrant 2 there. This is quadrant 1 that goes through, goes through the x-axis there, and quadrant 3 and 4. So 1, 2, 3, and 4. And we've got solutions here in quadrant 1, here in quadrant 4, because cos is positive in those quadrants. So cos theta equals 1/2. Let's get the little triangle out and see what angle that is. 1/2 is this 1, 2, root 3. Remember this is the equilateral triangle. So cos of which angle equals 1/2? It's that angle there, isn't it? And that angle is, in degrees, 60 degrees. So that angle there that's 60. And so what's that one there? It's 360 minus 60, isn't it? So our results are, if you like, you can look at it like this: 60 degrees here and 60 degrees here. So that 60 degrees and 300 degrees are our two solutions. So theta equals 60 degrees and 300 degrees. So remember what we're doing the reverse now, if you like. We're finding out the angles that give us an x-coordinate of 1/2. So that is, if you want to have a look at it in that sense, we're going to where x equals 1/2. That's 1/2 there. When x is 1/2, and it'll also be 1/2 down here somewhere. So that little angle in there is 60. And so that's 60 and that's 300, our two solutions. Okay, so moving on to another example, let's solve cos theta is equal to square root of 3 over 2. Okay, so on this occasion, we're looking for the angle that gives us root 3 over 2. So again, we go into this triangle here, cos theta. Now we're looking at that angle in there. We're again looking for angles of theta between 0 and 360. That angle in there is equal to 30 degrees. So what we need to acknowledge here is that we've got solutions in this quadrant and this quadrant, because cos is positive in those two quadrants, and this is a positive ratio. And the angle that gives me this ratio of root 3 over 2 is this angle here, which is 30 degrees. So I'm after a 30-degree angle in this quadrant and a 30-degree angle in this quadrant, which leads me to the solutions theta equals 30 degrees and theta equals 360 minus 30 degrees, which is 330 degrees. Will give me the two solutions there. Okay, so let's have another look at another example. Solve for sine theta equals, let's go for minus 1 over root 2. Again, between 0 and 360 degrees. Okay, so sine theta, where is it? Negative, not there, not there. It's negative in these two quadrants. Minus 1 over root 2. What is that? That is a little, that's a little isosceles right angled, isn't it? 1 over root 2, that one there, 45 degrees. So I want 45 degrees here, and I want 45 degrees here. So my solution is theta equals 180 plus 45, or 225 degrees, and 360 minus 45, which is 315 degrees. Two solutions. Okay, let's have a look at a different sort of question now, in that our numerical value here that we need to sine x to equal is 0.1. So it's not one of these exact value types, 1 over root 2. You could identify these by the sides in these little triangles that we've been looking at. 0.1. So we're off the scale a little bit there. This is not an exact value. This is going to be a calculator exercise. So x between 0 and 360. So let's go to the calculator and find out what this angle here is. Now, what we do there is we take sine x. So we're looking for sine inverse 0.1. Take sine inverse, please. 0.1. 0.1. Do you think you can do that? 0.1. 0.1. Thank you. And it's, oh look, I'm in radians here, I reckon. 5.73. I'm going to go in here, get my settings sorted out. Document settings. Angle, degrees. Okay, that's fine. So let's go back to the calculator. What was that result? Oh dear. Okay, it is 5.7 degrees. It just looked like almost too small for a degree, but when you think about 0.1, 1/10 small angle. Okay, so that's 5.7 degrees. So x is equal to 5.7. We'll just take it to one decimal place. But now let's think about this, because now we're looking at the sine curve here, and if we were going to graph the sine curve, so what we're looking for, we're picking up at 0.1. If this is 0.1 here, we're picking up these angles here, aren't we? That's 5 degrees. We're going to pick up this angle here, then that's going to be it. It'll be those two angles in the first two quadrants. So we need to pick up this 5.7. We need to grab it in the second, right? Because we're in these two quadrants for sine being positive. So 5.7 here, but 180 minus 5.7 here. So our other solution is 180 minus 5.7, alright, which is 5.7 degrees. 180 minus 5.7 is 174.3, everyone knows, degrees to one decimal place. Alright, let's look at another type, another similar type there. So cos x equals, solve cos x equals minus 0.7. But now let's go from 0 to 2 pi. So let's change this up to radians. I'm going to have to go in here. I'm going to have to change my settings now. It's a bit of a pain. Into radians. There we go. Into radians. Okay, good. Go back in here and find out. Now I'm not going to find out what cos. I'm not going to put minus 0.7 in. I'm going to put in 0.7. I'm going to forget the negative for the moment, because that's just telling me what quadrants I need to go into. No, I hit that button before. It's the wrong thing to hit. Don't be an idiot. Okay, so it's cos inverse, thank you, thank you, thank you. This thing is in. Okay, I got my calculator under control now, so I'm just putting 0.7 in here and hitting enter. Now that's in radians, isn't it? So 0.795. Let's go with 0.795. So x is equal to, now this is 0.795, 0.795 radians, right? But we're in the negative quadrants for x. Okay, so we're in the, not that one, and that one. So we need to put 0.795 in this quadrant here, 795, and in this one here, 0.795. So my solutions are not 0.795 at all, but pi minus 0.795 and pi plus 0.795. They're the two solutions because they're the ones that are, you know, so I take 0.795 from just finding cos inverse of 0.7, forget the negative, I get that value, and then I put it into the appropriate quadrants for cos being negative, which are quadrants 2 and 3. Quadrant 2 is pi minus 180 minus, quadrant 3 pi plus 180 plus. So I'm going to now put these values in to my calculator. So I go down here to my pi button, pi, thank you, pi plus, I'm going to pick up that value there, enter, and hit enter again. So I got 3.94. Right, so this is 3.94 rads, and pi minus that, I need to pick up that value now, so I go in again, pi, thank you, pi minus, right, that value there, enter, equals 2.35, so 2.35 radians, and these are my solutions. So x between these values of 0 and 2 pi in one revolution can be 2.35 radians or 3.94 radians to solve that equation. We're going to do one more example. Okay, our last example. Here it is. Now, we notice a couple of things different about this. Sine 2 theta, that's the first thing. It's not sine theta or sine x, it's sine 2 theta. Right, note that. Equals root 3 on 2, root 3 on 2. Let's use a little triangle. We just keep drawing these up and get good at them. Root 3 is there, 2 is there, 1 is there, and sine is that angle in there. So this is, for pi, for radians, pi over 3, 60 degrees. Right, so pi over 3, lock that in. That's going to be a big player in this solution. But also look at the domain I'm asked to solve between minus pi and pi. This is being quite difficult. So first thing to note is that that's my domain for pi, but I'm solving for 2 pi. So the first thing I'm going to do is I'm going to look at the domain for 2 pi. Right. So what that means is I'm doubling each of my extremities there. So I'm looking for 2 pi values between minus 2 pi and 2 pi. Excellent, righto. Now we can solve this. 2 pi equals, okay, I know what it is because I've got my little triangle over here. It's pi over 3. Pi over 3. Okay, fine. But I need my solutions to go 2 pi. So I need another one, don't I? Now sine's positive in, this is all stations in those two. So can I have another solution for 2 pi, please, but in this quadrant? Alright, what's that equal to? It's pi over 3 in here. Alright, what does it look like over here? It looks like pi minus pi over 3, which is 3 pi on 3 minus pi on 3. That's 2 pi on 3, isn't it? 2 pi on 3. Now, they're the only two solutions between 0 and 2 pi going that way. Okay, so I'll stop there. And now I'll go back the other way because I need some solutions that go back to minus 2 pi. So I want this solution here going back this way. So this is tricky. How do you feel about this? So now I want this solution here. So that is, what's that equal to? That's minus pi, because that gets me to there, minus pi on 3. So minus 3 pi on 3 minus pi. So it's minus 4 pi on 3. Put this down here, minus 4 pi on 3. That's that angle there. Got one more to pick up. It's this one here going in a negative direction, which is minus 2 pi, it's all the way around, plus pi on 3. Right, so I get this back into minus 6 pi on 3 plus pi on 3, so that's minus 5 pi on 3. I reckon I've got my solutions, but they're all for 2 pi. So now I just go back, and the last step is to divide through by 2. So theta equals, well, I'm going to go from my lowest value, all these are going to be divided by 2, minus 5 pi over 6, because all these equal 2 theta. Was I saying pi before? 2 theta. These are all my 2 theta solutions. I need to divide by 2. So that's my smallest solution. Minus 4 pi, I'm going to divide that one by 2, which is minus 2 pi on 3. I'm going to divide this one by 2, which is pi on 3. I'm going to divide this one by 2, which is pi on 6. Actually, those two need to switch places if I am, in fact, going to go in ascending order. But they're my 4 solutions. They all fit between minus pi, you see, and pi. And a few steps weren't there? A few steps. I had to firstly establish what 2 pi had to be, right, in my positive direction and my negative direction. But I firstly decided that, okay, if pi is pi, I keep saying pi, if theta is between minus pi and pi, then I'm solving for 2 theta. So I need to double my domain. So it's going to go from minus 2 pi to 2 pi. So I get all my solutions in that domain for 2 theta. And then my last step is to divide through by 2, because I want to solve for theta, not 2 theta. So there's my solution. Wow, that's a long YouTube. I apologize for that. We want now to do, there's quite a bit of stuff in there though, isn't there? All right, we're going to spend a day or two solving trig equations. Exercise 16I, starting on page 470. That's our next task. I'll see you soon.